methodology where it will have no effect on the no harmful effect on the nature. So copper oxide nanoneedles has great applications in solar energy conversions, high temperature superconductors and batteries. So peltoperum pterocarpum, so it's also called, the common name is yellow flame tree. So leaf, we have taken the leaf extract of it, and it has got antibacterial, antifungal and antioxidant properties. So in order to determine whether we have obtained like copper oxide needles or not, so we have performed a couple of characterization techniques. So some of them are XRD, FTIR, UV, then zero potential and semi-rex. Then we use these copper oxide nanoneedles for the click chemistry reactions, and we have used these as the catalyst. At last, we have taken the application part, and we have used these copper oxide nanoneedles. It is used as an antimicrobial and antioxidant agents. So this is the tree from which we have taken. So this is a peltoperum pterocarpum trees. So in Kannada it's called Bettadavuli. So this is the leaf, and we just crushed it and we did other things, filter, and at last we got this as a copper oxide nanoparticles. So this is the methodology in which we have synthesized the copper oxide nanoneedles. Initially we took the peltoperum pterocarpum leaves, then we boiled it and we boiled it in milky water, and then filtered, we got the aqueous solution, and then we took copper sulfate solution. Along with that we added starch to it as a stabilizing agent. Then we took this formed PP solution, that we say PP for peltoperum pterocarpum here. So we took that PP solution and we just poured it into the copper sulfate and starch solution. Then we added NaOH in order to maintain pH. So initially chemicals, fragments and all. So we need to maintain the pH. That is then we have added NaOH. We stirred it for 2 hours, and then we obtained a greenish blue color solution. We kept it overnight, like 2 days and all. Then we could see a color change from greenish blue to copper oxide nanoneedles turned brick red PP, and then we allowed it to settle. Then we centrifuged and then we took the sediment part, and then in the wash glass, and we dried it in the hot oven. Later we obtained powdered copper oxide nanoneedles. This is the scheme by which we have synthesized copper oxide nanoneedles. So let us go for the calculation. So now we have synthesized copper oxide nanoneedles, but how will you come to know we have synthesized? Like, see, this is copper 2O, that means copper is in +1 form. So initially we took copper sulfate. So copper sulfate, in that copper is in +2 state. So basically we are reducing copper +2 to +1, and we are using peltoperum pterocarpum in as a reducing agent. So it is reducing the copper from +2 to characterization method. In this is the first one, XRD, powder XRD. So these are the diffracting angles, 29.8, 36.4, 42.4, and these are the diffracting angles. And for corresponding diffracting angles, we got the corresponding Miller indices as 110, 111, 200, and so on and so forth. So this 111 peak and 200, so these are the prominent peaks, which will tell that copper 2, like Cu2O, that is copper +1 has formed. So we just verified these with the library powder XRD library values. Then we came to know that we have obtained the copper oxide +1 state. So these were in good argument with the GCPDS cardinals. Then we went for the cell. Cell is nothing but surface electron scanning electron microscope, where we are using electron beam, and we are hitting it on the sample, and then whenever the sample is emitting back the electrons, secondary electrons, those are taken by the detector, and hence we get a graph. And these are the very wonderful graphs. You can see we have got a magnification graphs with the clarity. So initially this is the it has a smaller magnification. Then this is the second one. This is the third one. We can see that copper oxide nano, see what happens is, whenever we take copper sulfate, as the initial agent, during the literature survey when we did, so we saw that most of the copper sulfate were giving copper oxide nanoparticles in a spherical form. But here, to our surprise, we found that our copper oxide nanoparticles were in needle shape. So this was quite surprising for us. So that is what we have reported here. So by interestingly, we are saying that we could find the shape of copper oxide nanometers to be in needle form. This was a bit different from the trend that was going on. So coming to EDX, EDX is the energy dispersive X-ray spectrum. So here we are, this technique is basically employed in order to understand what are the contents present and in what composition they are present. So we can see that we have obtained sodium as a higher peak, and also we have got carbon, oxygen along with copper. So copper has got a weight percentage of 36.07% and atomic weight percentage of 13.83. So here we have got sodium as the peak. Though we have copper oxide, so copper and oxygen obviously they will be there in this peak. And carbon, it is because of the, since you have taken the leaf, so leaf extract definitely it will be having the organic content. From that the carbon might have come. But what about the sodium? Sodium, we have used sodium hydroxide as the stabilizing agent and also as a in order to maintain pH. So there is sodium. So if I go to the previous slide, you can see that in some images here there are the interstitial sites in the crystals of these nanoparticles, and there the sodium has got captured. So sodium hasn't come out. We try to wash it with water and all, but it couldn't come out. So they were captured there itself. Because of that, we are getting the sodium peak. And if I take you exactly, it is 0.7 somewhere it is. So this is the sodium peak. So by this we can say that our compound, whatever the nanometers we have got, so it is containing carbon, oxygen, copper, and sodium. So next comes the FTIR, that is the Fourier transform infrared. So here this particular graph tells us, the spectrum tells us about the formation of copper +1 state. So we know that whenever there is formation, whenever we have got a copper in +2 state, then copper oxide. Shall I write this? So if I have copper oxide, then copper will be in +2 state. This is mentioned. So this bond, so this vibrational, stretching vibrational, this will be around 50, like it will be 15-20 in that range. But here we got 890 per centimeter. So it clearly shows that, and this peak is missing. This peak is missing. Initially, if you would have taken the FAI for copper sulfate, definitely you would have got this peak. But because there is no such peak of 15-20 there, so it has disappeared. So it means that, and also a new peak has arrived at 890. It means copper +1 has appeared. So that is also evidence which tells us that copper +1 has formed. This is UV. So we have got the lambda max, the highest absorption peak at 550 nanometer. So when we took the UV spectrum for the leaf extract, at that point of time it was around 320-330 nanometer. But now when we got the needles, we got at 550. There is a drastic change from 330 to 550. So it is around like increment of 200 odd nanometers. So that increase, that red shift, it is because of surface plasma resonance. So that is the phenomenon that is occurring there. So whenever the light rays hit the metal surface, then that will set the electrons in oscillations, and because of that there will be increase in the lambda shift, and also it will help in optical properties are increased. So this is the particle size and zeta potential. So particle size, it is basically it is used to measure what is the diameter and particle size and all. So when we did this, we could see the particle size coming around the, whenever we talk about the nanoparticles, we say the particle size average. We never say particle size of particular like structure. We always say average, because why we say is because all particles will not be of the same diameter and size. There some will be small, some will be large. So because of that we take average. So we take average and we get one value. So if for average particle size we got 94.8. So if it is coming below 100, that means we have got nanoparticles. So see, it is not only the particle actually, but because we have used water as the dispersed medium, so even the water molecules have added around the copper oxide particles. So we are taking, like, if this is a copper, copper 2 oxide particle, then we have got even water molecules added to it, like this. So this entire distance, entire diameter is 94.8. So if this is 94.8, definitely this particle, the copper oxide, will be definitely less than 94. That will be, it will be less than 100. So hence we can say it as a nanoparticles are formed. So other one is zeta potential. Zeta potential is here in this graph you can see that the peak has appeared at exactly at 67.7 millivolt. It means it has come at the positive side. So positive side means the copper oxide nanoparticles is carrying the positive charge. If this copper oxide nanoparticles, if this is carrying the positive charge on its head, as I earlier mentioned, we have used water as the dispersed medium. So OH will be there. OH will be acting as a negative, and they will be surrounding this positive charge. And there is a difference. So if I say word potential, potential means something which is related to difference. If I take a overhead tank in front of our house, that storage tank, and lower tank, the water will flow because of potential difference. In the similar fashion, so there is a positive and there is a negative sign. So the difference is zeta potential. The potential formed there. So that potential came to be known about 67.7 millivolt. So what is the measurement of the potential difference? So since we are getting in the positive side, so we can say that copper oxide nanoparticles is surrounded, like it is made up of positive sign. And one thing we need to know that when we are talking about the zeta potential, minus 20 to plus 20 if the value comes, then we say it is unstable. But if it is exceeding plus 20 or negative minus 20, let the sign be negative or positive, it is immaterial. But it should exceed 20 or it should go beyond minus 20. Then we say the structure whatever form, it is highly stable. So this is the click chemistry. So I have taken an image analogy. So click word exactly. The click has come from this buckle. So this buckle and socket. This is socket and this is the buckle. Whenever we just tie the belt and all, when you just put this buckle into the socket, we get a click sound. So that is how the click reactions are also happening. We are just joining the two different entities. So that click sound, this click chemistry has come from this click sound that is appearing from this. So that's the output. So click chemistry was for the first time it was introduced by K.V. Sharpless in 2001. And these reactions are highly stereospecific. They give high yield and they are simple to perform and can be conducted in milder conditions. So here we have used, as initially mentioned, copper oxide nanoparticles are used as a catalyst for our click chemistry reactions. So here initially we took the benzyl bromide and we took sodium azide, and at room temperature in the presence of THF and water in the ratio 1:1 we took the solvent. So we obtained benzyl azide. So it's a nucleophilic reaction. The negative charge is attacking here and we are getting out. So that's the product. So we are obtaining benzyl azide. So we took the same benzyl azide and treated it with an alkyne. So reaction of azide with alkyne. So whatever product we obtained, this is a click reaction product. So we obtained a triazole here. So it's a 1, 3, 4. It's a 1,4 triazole product. It's a 1,4 triazole product. So doing these reactions, when we were doing our project, we took two compounds. Like we replaced R by initially H, and in another compound we replaced R by CH3. These are the two things we replaced, and we got in place of R, one is H, one is CH3. We obtained two products and we named it as 4D and 4E. So let us come for the 4D FDIR. So now we are going into deep diving into the characterization of the triazoles that we obtained. So this is the first one, 4D. So if I look at the peaks, so we obtained for FDIR, we obtained 3 peaks, 3, 1, 4, 2, which is
next step.
So this is the proton NMR. So I am concentrating on 2 peaks, major peaks. One is the methylene proton and the C5 proton of the triazole. So methylene proton it got resonated. That proton got resonated at the value 5.56 ppm, and triazole C5 proton got resonated at 7.65 ppm. And other peaks, they like the aromatic peaks, they were in the range of 7.2 to 7.4. And these two protons basically they give higher values than the other. So the like 1, 2, 3, 4, 5, 6, 7, 8. These 8 protons give a multiplet in the range of like 7.3 to 7.4. But these two protons were way higher. Like it was around 7.7 ppm. It is because like it is attached to the electronic atom and also nitrogen is present because it is de-sheeted, so it is showing at higher value. So now this is the C30. So I have taken the same carbon, so that it will be easy for us to compare things. So this carbon, particular carbon, sp2 carbon, sp3 carbon, it gave C30 value at 54.31 ppm, and this C5 carbon gave at 130.60 ppm. And other carbons give at respective aromatic and aliphatic regions. So this is the mass spectrum. So we did this mass spectrum in order to analyze what is the exact molecular weight of the compound. So the molecular weight, molecular peak came around 236 and base peak was 57. So this is the molecular formula of this compound. C50 H39 N3 is the molecular formula and base peak was 57. So but when we calculated exactly like taking every element's mass and all, when we calculated, we came it came almost close. It was 235.28, but in molecular peak it was 236. So almost we were quite close. So this is the SPR of the second compound. This is the proton NMR. So as earlier mentioned, so all things were same, but the thing was this was the resulting of same like 5.55 itself, and this also was 7.65. The variation was here because we have got introduced a methyl group. So these all initially we were having 5 plus 3, 8 were giving a multiplet. They were of the same genre. But now what happens is these two protons, because of difference in the surrounding nature, electronic nature. So this is giving a doublet and this is also giving a doublet, but at the different values. This will be giving at a greater value when compared to this because it is very near to nitrogen atom. Because of that it will be highly shielded. Highly de-sheeted, but here you got methyl, so it will be less sheeted. So other things will be, these 5 will be giving at a multiplet and this will be giving at 2.34 ppm. It's a sp3 carbon CH. So this is for C30 NMR.
Next step.
This is the
Next step.
So now, till now we did all the characterization of like initially we started.
Next step.
So you don't like it. So copper oxide nanometers here we used as antimicrobial and antifungal. Sir, it is like soldier is killing all the enemies in the similar fashion. This copper oxide is using it's like a soldier and it is killing the microbes. So these are the microbes it is killing. So first one we used it as an antioxidant. So when I talk about antioxidant, first thing oxide. So oxidation means removal of electron. Oxidant is an agent which is going to remove electron from the biological system. Now, if there is an oxidant in our biological system, what happens is it will start taking electrons from our system. Because of that, due to the change in the electrons in our system, entire the functioning of the body will be harmed. So we need to curb the activity of that oxidant. For that we use anti. Anti means opposite. So we are using an agent which is opposite of that oxidant. So here we use the DPPH radical scavenging acid. So DPPH means 2,2-diphenyl picril hydroxyl radical scavenging. So this is the compound that we are using. So we use standard compound as ascorbic acid as the standard oxidizing agent because we need a reference point so for comparison. So IC50, this is nothing but the amount of drug that we need to give to that particular organism or the compound in order to kill or neutralize the 50% of the inoculum that is present. So that is IC50. For that IC50 for ascorbic acid was around 26.38 microgram. But IC50 for copper oxide nanometers that we have already prepared, it came to be known around 94.80. It is way greater than this. That means, so to kill, like if I want to neutralize 50%, then I need to just supply 26 microgram, that dosage. But to neutralize 50% of the microbes, I need to give for copper oxide minerals, I need to give 94. Definitely this is less potent than that, but at least it is showing the antioxidant nature. So this is the working of DPPH as I earlier mentioned. So this is the radical. So two diphenyls and nitrogen. Initially it will be hydrogen, then we got two phenyls and picric acid. And this nitrogen is having a lone one single electron. Single electron is acting as a free radical. So this is the RH. So this is basically an antioxidant. It is going to give one hydrogen. Hydrogen is nothing but an electron. So as soon as you give an electron, this one electron will come here and a bond will be formed. H will be formed. And that will get converted into hydrogen, will get converted into hydrazine. So when this radical is stabilized, then no more it will start taking the electrons from a biological system, it will be neutralized. So that is happening here. So H have been introduced, and this becomes a 2 this is 2 diphenyl picryl. So this is the IC50. So in order to neutralize 50% of the antioxidant, so we required around, it is 95 micrograms. But here ascorbic acid, it is requiring around 23 to 24%, 20 to 23 microgram per ml. So this graph will show us the potency. So now what I will give is, I will give for PP, that is the peltoperum and A, both I will be giving a 10 microgram itself, the same amount. Now we will see what will be the scavenging activity. Scavenging activity is neutralizing ability. So what will be the activity? So I gave initially I took pure, that means 10 gram I gave. This was showing only 5%, this is showing 20% of the activity. Means 4 times more potent. So PP, now when I gave about 20 gram, it was showing 10%. Here it is showing 30 to 35. So in the similar fashion, when I got 50, then it is showing around 90%. So this is the residue based microblog dilution method. So So this is antibacterial agent. So antibacterial are basically agents which are going to kill the bacteria.
Not
So
kill, may kill or may not be.
Make static about suicidal, yes, both of them. So it depends upon the concentration. So
Which is
here,
better? Which is better? Suicidal better or static better?
so it depends upon the condition. Like if it is required static, suicidal will be definitely finished.
Static.
No,
Size, which is better?
Suicidal.
Suicidal better.
But ಅದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಭಾಳ ಕೊಡಬೇಕು ಸರ್ ಆ ಪೇಷಂಟಿಗೆ ಅದು ಮತ್ತೆ ಅದು ಅವ್ರ ಮ್ಯಾಗೆ
ನಿಮ್ಮದು ಅಮೆರಿಕ.
So here we are using minimum inhibitor concentration MIC.
ಸರಿ.
So this is the amount of concentration that we need to give in order to inhibit the activity. So we have used amoxicillin and ciprofloxacin as a standard antibacterial agents. So the copper oxide nano showed good antibacterial activity against gram positive and gram negative. So this is antibacterial. So this is the overall aura. So here we have used Streptococcus aureus and Escherichia coli as the bacteria. So we have taken PP here. So the pink color turns like here you got pink color, you got blue. It means if there, so every enzyme, the immune system has got the ability to convert like it has dehydrogenase enzyme is going to reduce the content. So resorine is converted into resorphin and hence color change will be there. If the pink color is there, it means bacteria is still present and they are reducing. But once the blue color remains intact, if there is no change in the color, if it remains blue, that means bacteria has died. So there is no bacteria present. So you can see the minimum inhibitor concentration. So it is 8 microgram per ml. So that is the I have written here. MIC for PP against gram positive. So Streptococcus aureus is used as a gram positive and E. coli is against a gram negative. So gram positive, gram negative basically they are for staining. So by if the bacteria retains the stain, then it is gram positive. If it doesn't retain, then it is a negative. So MBC is completely if I want to kill the bacterial inoculum itself, then I need to supply 128 microgram per ml of drug. But look at this amoxicillin. So I need to supply 0.5 microgram per ml in order to inhibit the activity. It's like if a thief is running and if I want to if a police are running behind him. So if I want to stop him, so if the police will not hit the headshot, you hit the shot at his leg so that you want to stop him, not so that he doesn't run away. If you hit a shot, you will arrest him. So we are arresting that robber's activity. So inhibiting. But if we want to completely kill him, he needs 4 to 5 minutes. So in the similar fashion, if we give smaller concentration, it will be inhibited. If we give higher concentration, it will be killed. So for ciprofloxacin, it is again like active against gram-negative and amoxicillin against gram-positive. So it is antifungal. Antifungal is the agents which are going to act against the fungus. So here we used So we used Candida albicans and Candida glabrata as the two standard as the fungus So we used fluconazole and itraconazole as the standard drugs. So copper oxide nanodrugs was twice potent for Candida glabrata when compared to C. albicans. So this is the antifungal activity as earlier mentioned about MIC-MBC. So for C. albicans, it was showing the activity at 128 microgram, but for C. glabrata, the PP was showing its antifungal activity at 64 itself. That means PP is more potent against Candida glabrata when compared to C. albicans. So those are the values I have put here. So fluconazole, for just if I give 8 micrograms, suddenly it is showing its activity, and itraconazole initially like 4 itself, it is showing its activity. These are the controls. Positive means the bacteria are still alive, like the pink, they are still alive. Negative means like you see this. If you want to plot a graph, then in order to understand what are the scales and all, we write the scale at the corner. In the similar fashion, we are using it as a control reagents. So if it is negative means negative means that it has died. So that is the indication mark. So these are the conclusions that we can draw. The copper oxide nanodrugs initially they were synthesized from pterocarpum leaves. Then we did all the characterization methods in order to verify whether we obtained needles or not. Then we did the click reactions where we used copper oxide nanodrugs as a catalyst for click reactions. Then the spectral calculation was done using FTIR, proton NMR, C13 and mass spectroscopy. Then copper oxide nanodrugs were also used as antimicrobial, antifungal and antibacterial agents. So antioxidant if we look at the potency, then you can see that PP was 4 times less potent than that of ascorbic acid, but it showed good and it was more effective when we compared for the antifungal. It showed more effectiveness for the C. glabrata, that is Candida glabrata, and it showed good activity against Streptococcus aureus when we are talking about the bacteria when compared to E. coli. Thank you. So thank you.
Introduction cover. Next step. ಈಗ iron extract ಮಾಡಾಗಿಲ್ಲ, which is now used green. Now it is dried. Is used or as such?
So initially we plucked the leaves and we dried in shaded area for 2 to 3 days. When it got dry, then we crushed and then we boiled in milk water and then we provide the solution of it.
Boiled and solution impact.
Other solution extract liquid bರುತ್ತೆ.
How you extract?
Filter
water, just whatever boiled solution.
Boiled solution in the water filter
water.
water. Milk water ಒಳಗೆ ನಾವು ಬಾಯ್ಲ್ ಮಾಡಿದ್ವಿ ಸರ್. ಬಾಯ್ಲ್ ಮಾಡಿ ಅದೇನು ಸೊಲ್ಯೂಷನ್ ಬರ್ತದೆ ವಾಟರ್ ಫಿಲ್ಟರ್ ಪೇಪರ್ ನಂಬರ್ 2 ಲೆ ಫಿಲ್ಟರ್ ಮಾಡಿದ್ವಿ. ಫಿಲ್ಟರ್ ಮಾಡಿ ಏನು ಬರುತ್ತೆ ಅದು ಲೀಫ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ತಗೊಂಡು ಅದು ಅಕ್ವೇಸ್ ಸೊಲ್ಯೂಷನ್ ಆಗಿ ಯೂಸ್ ಮಾಡಿದ್ವಿ ಸರ್.
ಅದರ pH ಎಷ್ಟಿತ್ತು?
So initially it was acidic sir.
Acidic. Full acidic. But it is now
like 3 to 4 pH.
Highly acidic. 3 to 4. Okay. ಅದರದ್ದೇನು ಆಯಾರಿಗೆ ಯಾರು ಮಾಡಿಲ್ಲ?
ಕಾಪರ್ ಆಕ್ಸೈಡ್ nanodrugs ಆದ್ಮೇಲೆ
ಅದರದ್ದೇನು ಆಯಾರಿಲ್ಲ. ನೆಕ್ಸ್ಟ್ we are not reporting now single time magnesium iron. Most of them use now like use content discard chlorophyll. Hidden.
Yes.
If you do such magnesium will come. And the copper oxide preferable, magnesium oxide is more preferable form. Aqueous PP ಬರ್ತಲ್ಲ, that's like solution second beaker.
sir, aqueous solution. Sir, aqueous solution of PP.
What colorless ಐತಿ?
Also ಸ್ವಲ್ಪ brownish
Self-production.
Self-production.
So next one. You just you compared this one. There is no other. You said it is copper. Generalized comparison you made it with library or as such copper oxide is there like you made it.
Like Cu+1 ಜೊತೆ ನಾವು ಕಂಪೇರ್ ಮಾಡಿದ್ವಿ ಸರ್.
ಬರೀ ಫಕ್ತ.
ಅದರ ಮಿರರ್ ಇಂಡೆಕ್ಸಸ್ ಇದರ ಮೇಲೆ ಮ್ಯಾಚ್ ಆಗಲ್ಲ ಸರ್. ಸೊ ಅದಕ್ಕೆ ನಮಗೆ ಮೇನ್ ಬೇಕಾಗಿದ್ದು ಇದ್ರೊಳಗೆ +1 ಆಗೈತೆ ಅಂತ ಅದು ವೆರಿಫೈ ಮಾಡೋದು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಸರ್.
ಮತ್ತೆ there is no any +1 other like elements which are there.
So ಅದು ಮಿರರ್ ಇಂಡೆಕ್ಸಸ್ you like if this peak 200 peak, so these two peaks were definitely for copper +1 itself.
That's why I just asking.
Sir, but yes sir, but I don't know exactly like what is these, whether they may be like even it may be containing like +2 also if it is not completely converted. There may be some traces of that maybe.
So many library means plenty of lab systems are there. Just for sake of your known compounds, you are saying extraction comparisons for purpose. The percentage which you quoted no here. Somewhere the EDX is it? EDX you show how much percentage? 36%. Just imagine the calculations, if you percentage calculations. 36 copper.
64 is the
rest of the you say the carbon, oxygen. If you comparison to how much oxygen is there? Calculation can it possible?
Sir, oxygen here.
Now again 2 more peaks will have the percentage which is there.
Sir. The like I just there it was a table and it was like all values. Sir, I just took the top of it. Like sodium was the maximum, sir. It was like 44 matta in itself. But
you added there, no?
Sir.
Sodium and
ಅದು ಅಲ್ಲಿ ಅದು ಲೈಕ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಒಳಗ ಇಂಡಸ್ಟ್ರಿಯಲ್ ಸೈಟ್ ಒಳಗ ಸೋಡಿಯಂ ಅನ್ನು ಕ್ಯಾಪ್ಚರ್
ಆಗಿದೆ. ಅದಕ್ಕೆ ಸೋಡಿಯಂ ಏನು ಹಾಕಕ್ಕೆ ಬರ್ತಿದ್ರೆ ಬೇಸ್. That is itself you can use it as a stabilizing agent instead of starch, sodium hydroxide.
Easily available, sir.
Easy, many other layer easily available. And the better we can see avoid the which is the generations, coordinations, everything. Better we can enhance them. So next step. Now this is IR. Now transparency looking into now it is around like 65%, 60 or 70% transparency. Is it? Rest of the 45%, only 45% absorption. Iron element, how you done this is iron?
KBL pellet ತಗೊಂಡು ಸರ್.
KBL pellet ತಗೊಂಡು They will say now sifting of this red sift. And this material. This large is red sift copper oxide. It has standard value of absorption to ED transitions if you are looking into the EV absorption factors. Now in their case it is getting around 300 something. Pragati? Something. Now it's sifted now 550. The methodology is same, reagent use same, just for sake of change the surface used the material.
So source
Surface,
so source change ಮಾಡಿದ್ರು like ಅವರು
which kind of source you use?
like a fruit and what was the name?
That's not it.
So we are using
Size of nanoparticle how much you are getting?
less than 100.
So you are also getting less than 100.
Source matter ಆಗಲ್ಲ ಸರ್.
How you justify the source?
Like structural variation ಆಗುತ್ತೆ ಸರ್.
Now structure there is no any such organic molecules to show such kind of absorption. Other than organic molecules, if we have such kind of more than like 500, those are the better which you can use it now like OLE materials. If we calculate the band gap between that one.
Yes, 2 electron volt. So ಅದಕ್ಕೆ surface plasma resonance phenomena ತೋರಿಸಿ
ಪ್ಲಾಸ್ಮಾ ರೆಸೊನೆನ್ಸ್ ಎಷ್ಟು ಶಿಫ್ಟ್ ಆಗುತ್ತೆ ಇಷ್ಟು 200 ಗಂಟೆ 200 ಗಂಟೆ ಶಿಫ್ಟ್ ಆಗ್ತದೆ ಯಾವ ಇದು ರೆಫರೆನ್ಸ್ ಆಯ್ತು plasma resonance they can explain based on the molecules which are there 5 transitions which we say on that basis shifting is explained not including the nanoparticles which are but you say now this is nanoparticles we are doing and there is no any matter to discuss the copper oxides in EV ಹೌದಲ್ಲ ನೀ ಅದನ್ನ ಹೇಳಕತ್ತೆ ಅಂದರೆ ಇ ವಿ ಮತ್ತು ಆಕ್ಸೈಡ್ಸ್ ಇದೆ ನೋಡು ಸೊ ಕಾಪರ್ ಆಕ್ಸೈಡ್ಸ್ ಎಲ್ಲಿ ಬರ್ತಾವೆ ವೇರ್ ಇಟ್ ಶೋ ಕಾಪರ್ ಆಕ್ಸೈಡ್ಸ್ ನ್ಯಾನೋ ಪಾರ್ಟಿಕಲ್ಸ್ ಇವಿ ಮತ್ತು ಈಗ ಅದನ್ನೇ ಮಾಡತ್ತೀರಿ ಅದನ್ನ ನೋಡ್ಬೇಕಲ್ಲ ಅವರು ನೋಡಿಲ್ಲ ನೀವೇ ನೋಡಿಲ್ಲ ಅದನ್ನ ನೀವು ಆಯರ್ದಾಗ ಹೇಳ್ರಿ ಮತ್ತು ಕಾಪರ್ binding value 790 something. ನೀವು ಏನಾದ್ರು ಆಯರ್ ವ್ಯಾಲ್ಯೂ ನೋಡಕತ್ತಾರೆ ಹೌದು ಹೆಂಗೆ ಹೇಳ್ತೀವಿ structures minimize at least minimum structures which are interacted with this kind of nanoparticles that is more useful because that tells that how basic transitions is to extend what in plasma is explained. That starts nothing to do with that. Is it? Starts nothing to do with it.
It is just stabilizing.
Stabilizing you are saying. Next up, ಹೆಂಗಾಗುತ್ತೆ ನೋಡಿ ಕಾಪರ್ ಆಕ್ಸೈಡ್ UV ಸ್ಪೆಕ್ಟ್ರಮ್ ನೋಡಿ ನಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ that is come in the result they say what you are explaining justified instead of being plasma resonance you would have said next up stylus that is the problem this is it only copper and clear we are not using copper RT PHF what we added we done result nanoparticle this one general consider title na not important but we like to this also taking simple version next ಇದನ್ನ ಧನ್ಯ ಮಾರ್ಕ್ ತೋರಿಸಿ that which is there CS2 ಇನ್ನೇ ಮಾರ್ಕ್ CS2 ಅಟ್ಟ ನೆಕ್ಸ್ಟ್ next one 5 at least now you can expect more than that
because nitrogen is
that is to expect more and that is getting now the singlet looks like singlet expand ಮಾಡಿ singlet is able to
ಅದು singlet is
sure expansion ಮಾಡಿ
singlet is sir
expand ಮಾಡಿ ನನಗೆ ಅನ್ಸುತ್ತೆ ಪಾರ್ಷಿಯಲ್
ಅದರಲ್ಲಿ ಸೈಡೆಡ್ ಗ್ರಾಫ್
ಪಾರ್ಷಿಯಲ್ is splitted ನಾವು ಇಲ್ಲಿ ಬರೋದು ಇನ್ನೂ ಡೌನ್ಫೀಲ್ಡಿಗೆ ಬರಬೇಕಾಗಿತ್ತಲ್ಲ ಅಂತ
ಬಟ್ ಲೈಕ್
ಯಾಕಾಗಿಲ್ಲ ಡೌನ್ಫೀಲ್ಡಿಗೆ ಯಾಕಂದ್ರೆ ವಿ ಮೇ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಸಚ್ ಕೈಂಡ್ ಆಫ್ ಮಲ್ಟಿಪಲ್ಸ್ ಲೆಟ್ ಮೋರ್ ಡೌನ್ಫೀಲ್ಡ್ ಬಟ್ ಬಂದಿಲ್ಲ ಎನಿ ಹೌ ಇಟ್ ಇಸ್ ನಾಟ್ ಬರಬೇಕಾಗಿತ್ತು ಬಂದದಲ್ಲೇ ಆಲೋಚನೆ ಬಟ್ ಸಮ್ ಟೈಮ್ ಯು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಇಟ್ ಇಸ್ ಮೋರ್ ಡೌನ್ ಸೀಡ್ if you place nitro group or things which are there in this para position daga or position daga you expect more than like 6.7 6.8 you high resolution and MR matter I think splitting you may observe this ಯಾಕಂದ್ರೆ ಸ್ಪ್ಲಿಟ್ಟಿಂಗ್ ಆಗುತ್ತೆ ಒಂದು ಟೈಮ್ ಆಯ್ತು ಅದನ್ನೇ ಎಕ್ಸ್ಪಾನ್ಷನ್ ಮಾಡಿ ನೋಡೋಣ whether it is double it is there or what Everybody in such kind of molecules, you just cross electrons, that come to know. Next. Very good. Okay, good. ನಿಮಗೆ ಒಂದು 10 ಮಿನಿಟ್ ರೆಸ್ಟ್ ತಗೊಳ್ಳಿ. ನಮ್ಮ ಕಾಂಪ್ಲೆಕ್ಸರ್ ವೇಟ್ ಮಾಡಕ್ಕೆ ಇನ್ನೂ ಎಷ್ಟು ಜನ 3 ಜನ?
ಹಾಂ ಸರ್.
ನಿಮ್ಮದು ಬ್ರದ್ದು ಸೇಮ್ ಏನು? ನೀವು 3 ಮಂದಿ ಡಿಫ್ರೆಂಟ್ ಐತಿ.
ಹಾಂ ಸರ್.
So thank you so much for giving such a wonderful process.
Thank you.